everybody, welcome back boys and girls. It's your main mathematics Shane coming to you live from Summit Academy. In this video, working on unit number 5, lesson 13. We're talking about the cylinders, finding the area of the base, and finding the volume of the actual shape. So for the first part, it says a circle's dimensions. Here is a circle. Points A, B, C, and D are drawn, as well as segments A, D, and BC. And it says what is the area of the circle in square units, and that says select all that apply. So that means that there's going to be multiple answers for this first part. So what we have to do is we can label this segment AD. This is going to be equal to our radius. So we can label that R. This is helpful because if we look at the area formula for the circle, we're going to say it's going to be area equals pi times the radius squared. And so if we calculate that, or if we plug in or substitute in what our values are, we're going to say that this is going to be, we have area equals pi times 4 squared, so 4 squared, which is the same as writing area equals pi times 16, because if we have 4 to the second power, again that's not 4 times 2, it's 4 squared, so it's 4 times 4, which is 16. And we could also say that's going to be the same as if we multiply this out, if we plugged in 3.14 for pi and multiplied it by 16, this would be approximately, let me say approximately 50.3. We could say units squared because we're talking about area. So which of these can we pick? Well, we can't pick that first one because it's only 4 times pi, and we can't pick that second one because it's going to be 8 times pi. However, the third one is good. The fourth one is good. We're going to say it's not approximately 25, and however, it is approximately 50. So make sure you can, write out those multiple representations of each of those areas. And for the second part, it says if the area of the circle is 49 pi square units, what is going to be your radius? And explain your reasoning. So we're going to say, well, if the area is 49 pi, we can say the radius, actually do different color here. Let's do orange. So we're going to say the radius is, or the radius squared is equal to 49. So if the radius squared is 49, this means, so we can say this means the radius is 7, since if we take the square root of 49, again square root of 49 is going to be equal to 7. So again, if you ever need to kind of work backwards, make sure you can use those steps logically. Alright, on the next part, it says circular volumes. It says what is the volume of each figure in cubic units? Even if you aren't sure, you can make a reasonable guess. For the first one, that figure A is a rectangular prism whose base is area of 16 square units and height is 3 units. And so anytime I'm thinking of the volume of something, anytime I think of the volume of something, I'm thinking of it's going to be the area of the base times the height. So I'm saying the area of the base is going to be that big B, that capital B. So area of base, and H is going to be height. And this is going to be volume, which is right here. Okay. So if I have the area of the base already, that means that this first one, all I have to do is I could say, well, if I have the volume, I'm going to say is going to be B times H, the area of the base times the height, which is going to be equal to 16 times 3, because that's going to be the area of the base times the height. And we can say that's going to be 48 units cubed, because we're talking about volume. So make sure you include your units on that answer. Next one is for that figure B. It says a cylinder whose base has an area of 16 pi square units and whose height is 1 unit. So same idea, volume is going to still be equal to the area of the base times the height, which is going to be equal to 16 pi times 1, which is just going to be the same as 16 pi units cubed. So let me make some space for that. Units to the third power. All right, and for the last one, that figure C, again, notice how it's almost like we're stacking each of those on there. It says a cylinder whose base has an area of 16 pi square units and whose height is 3. So now we have to multiply it by 3 instead. So let's do purple for this one. So we're going to say volume equals area of the base times the height. So it's going to be 16 pi times 3, which is going to be 48 pi. We have to have units cubed. All right. And for the next part, it says a cylinder's volume. So it says here's a cylinder with height 4 units and diameter 10 units. So anytime if you are looking at diameter, just remember that diameter is going to be equal to 2 times the radius. So that means that we could rewrite it. We could say radius is going to be equal to the diameter divided by 2. So that means for this one, our radius is going to be 5. So just make sure that you keep that in mind for this part. Then it says, for part A, it says shade the cylinder's base. And so what you can do, if you want to use, let me say, use different color for this. So that way you can say what you have. So let me say so what you can do is you can have just shade it in. If you want to use the highlighter, you can. So let me actually just do that. So let's just use the highlighter. So I'm going to highlight that base for ourselves, maybe do color that's actually visible. Let's do green, there we go. So I'm going to highlight one of those bases. Again, you have multiple options since the cylinder has 2 bases. You know, you can shade that bottom one, or if you wanted to, you could shade the top one. Either one matters. All right, so we want to use a different color to shade in that base, so that way it is visible. All right, so now that you have shaded in that base, it says what is the area of the cylinder's base, and we can express it in terms of pi. And so what we're going to do is we're going to find the area of that base. So again, we're going to find the area of that circle. So we're going to say big B, the area of the base, is going to be equal to pi times the radius squared. So we're going to say B is going to be equal to, our radius is 5, so we're going to say pi times 5 squared, which is the same as, so let me actually write that here. I'm going to say B is going to be equal to 25 pi units squared. So again, make sure you're saying capital B, that big B is going to be the area of your base. And it says, what is the volume of the cylinder? Well, we can kind of piece this together because we have parts of what we need. So we're going to say the volume is going to be equal to the area of the base times the height. And so we're going to say that's equal to 25 pi for our area of the base. And the height is 4, so we're going to say times 4. So we're going to say it's going to be 100 pi, and we're going to say units to the third power, since we're talking about volume for this one. Again, we leave that pi attached there because it's like we're multiplying by 3.14, but it asks for our answer in terms of pi. All right, so now the second one after that, it says a silo is a cylindrical container that is used on farms to hold large amounts of goods, such as grain. On a particular farm, a silo height of 18 feet and a diameter of a silo has a height of 18 feet and a diameter of 6 feet. Make a sketch of this silo and label its height and radius. How many cubic feet of grain can this silo hold? And then it says use 3.14 as an approximation. So you can make a sketch of this. So some key parts of this. Let's say some key parts of this. We need the height is going to be 18 feet. The diameter is 6. We're talking about a cylinder, and we want to label its height and radius. So we can draw it like this. So we're going to have, just like we did in the previous video, draw those two circles, or those two ovals, I should say. And we're going to say, here's these side lengths. It takes a little bit of practice, but for the most part, it doesn't have to be perfect. Let me dash this in. Actually, let's say, try that one again. Give it more of a curve to it. And that's going to be the bottom part. All right. So it says the diameter is 6. So we're saying, you know, the distance across the entire amount. The distance across the entire amount of the base, either base, we're going to say d equals 6. And that means that our radius is going to be half of that. So radius is going to be 3, since 6 divided by 2 is equal to 3. So let's just put that here. We can say this is going to be our radius. So r equals 3. And it says that the height is 18 feet. So let me write that down too. So height, so we're going to say h equals 18. All right, so first things first, let's highlight that base. Again, it can be either one. And we're going to say that, okay, we need to find the area of this base first. So I'm going to say that big B, we have our formula. Big B is going to be pi times the radius squared. So we're going to say big B is equal to 3.14 times the radius, which is 3 squared. So if we plug that out in, again, it's going to be 9 times 3.14, which is going to be, the area of the base is going to be 28.26 feet squared. All right, so that's going to be the area of our base. We need to find the volume, so we're going to say, all right, well, if we're looking for the volume, let's do orange again for that volume. So we said volume is going to be equal to the area of the base times height. So we're going to say volume equals 28.26 times the height, which is 18. And so our volume is going to be 508.68 feet cubed, because we're talking about volume now. So again, make sure you find your area of the base first. Then you can find your volume after you find that first part. All right. So now for those practice problems, towards the bottom it says match each set of information about a circle with the area of that circle. So it says it gives you a couple options. So it says, all right, the radius is this. So we're saying which of these would match up. Well, we're saying, you know, if we're talking about the area, so again, it gives us the radius on the left side and the area on the right. So we can say for that first one, we would say, you know, it's going to be pi times the radius squared, so 4 squared. So that's going to be 16 pi, so that's going to be A down here. So we're going to say that A is going to be that bottom one. For the next one, I can say the radius is 10. So if I do pi times 10 squared is the same thing as 100 times pi, which is going to be that second one, because if we multiply that out, I'm going to use that word approximately. We're going to say that number 2 goes with B. Number 2 goes with B. So now for circle C, it actually gives us our diameter, which we can cut in half, and we can say, well, our radius is going to be equal to 8, because half of 16 is 8. That means that if we have 8 squared, again, 8 squared is going to be 64, so that's going to be C. So C goes with 3. And process of elimination, our last one is going to be D. So we're going to say D goes with 1. But how can we get that? Well, we're going to say that if we have the circumference, we can say C equals 2 times pi, 2 times pi times the radius. So that means that if we have 2 times 2, we would say our radius for this one is going to be 2, and we have r squared is 4. So make sure that you can match those up very carefully. Alrighty, for number 5 on the back, real simple. It says just sketch that cylinder, label a radius. It's radius 3, and its height 10. So I'm going to tell you to actually, let's say, I'll actually show you how to do this one. So let's draw it horizontally, so that way it's a little bit different. So we're going to draw it on its side. Change it up a little bit. So we have our one side. Do that dashed line to give it some depth. And we can connect it like so. If I can actually draw this oval, and let's try from the bottom. Sure, close enough. Okay. So now it says, let's label its radius. So we can say, all right, let's label this radius. So from the center of one of the bases to the edge is going to be R. Let's do it on the outside here. Let's say R equals 3. And its height, H, is going to be equal to 10. And it says to shade one of its bases, so I'll do just that. So I can use a different color, shade one of its bases. And so I'm going to stick to shading that. I like shading that other side, so that way it's easier to see. And there's your perfect picture. All right, moving on. For the next one, it says, at a farm, animals are fed bales of hay and buckets of grain. Each bale of hay is in the shape of a rectangular prism. The base has side lengths 2 feet and 3 feet, and its height is 5 feet. Each bucket of grain is a cylinder with a diameter of 3 feet. The height of the bucket is 5 feet, which is the same as the bale. All right, so anytime you don't have the picture, always draw the picture, which is why we've been practicing. Some important information. That bottom has side lengths of 2 and 3, and its height is 5. And then for the cylinder, so the rectangular, so let's actually do that one first. Let's say the rectangular prism. It kind of looks like a cube, but the side lengths are different. So I have to make sure I label each of these sides. So what we can do is can draw something that looks like a cube, but you can draw a little bit differently. Same approach as before. Draw that rectangle, 3 parallel lines, and then you can connect those sides like so. Perfect. And let's label, so it has a base, and we can actually do that dashed line. Give it some depth. All right, so we're going to say we have side lengths of 2 and 3 on the base, and its height is 5. So make sure you have that outside of the mount is 5. All right, so we got our rectangular prism. Now let's draw our cylinder. So we're going to say our cylinder, the bucket is a cylinder, and it has a diameter of 3 and a height of 5. So let's draw our bucket, something like that maybe. Have our dashed line. It says it has a diameter, so be careful. Again, we're going to say our diameter is 3, so we say D equals 3, and that means the radius is going to be half that. So 3 divided by 2 is going to be 1.5. So I'm going to actually just write our radius for this one. So r equals 1.5. And its height is the same, it's still 5. All right, so now we have those pictures. It says which area or which is larger in area, the rectangular base of a bale of hay or the circular base of the bucket. So what we're going to do is we're going to say, all right, well, I need to find, can I actually shade it in white? Sure. Something like that. So we're going to do that base first. So I'm going to say, all right, retrace my base, redraw my base. My rectangle 2 by 3. Again, to find that area, multiply those two sides together, and we're going to say that area is going to be 6. Then we're going to say, okay, if we shade the base of the cylinder, we're talking about the circle now. So let's find the area of this circle where its radius, we're going to say its radius is equal to 1.5. So we're going to say area that this base, this big B, is going to be equal to pi times the radius squared, which is equal to, let's say, 3.14 times 1.5 squared. So again, make sure you can type that into Desmos if you need to check out how I get that answer. But we're going to say that the big B is going to be equal to 7.065. So which one is bigger? Well, we're going to say that the bucket's base is larger than the bale's base. So let's actually, can I put that right? Let's put that right here. The bucket's base is larger than the bale's base because 7.065 is larger than 6. And it says which is larger in the volume, the bale or the bucket, and explain how you know. Well, if I look at the heights of each of those, they have the same height, but if you compare the bases, if we just multiply those numbers each by 5, that's going to show which is larger. So let's actually do that. So if I find the volume of the, so let me actually keep it in white, so that way it matches up. So let's say the volume of the bale, volume of the bale is going to be equal to base times height, which is going to be equal to 6 times 5, which is 30. So the volume of that one is going to be 30 feet cubed for that one. And the volume of the bucket, there we go. Keep wanting to call them cylinders and rectangular prisms, but still the same formula. We're going to say area of the base times the height. So we're going to say that's equal to that 7.065 times 5, because it's times the height, which is going to be equal to, let's say, so our volume is going to be equal to 35.325. So we didn't need to do this, but I like to show how we get our answer. So real simple, we're going to say that, well, comparing these two numbers, the volume of the bucket is more than the volume of the bale. So make sure you can, show or at least think about it in terms of those volumes. You gotta make sure you're having units to the third power because we're talking about cubic units because it's a volume. All right. And then for the number three, for the next one, it says 3 cylinders have a height of 8 meters. Cylinder 1 has a radius of 1, cylinder 2 has a radius of 2, and cylinder 3 has a radius of 3. And it says to find each of those volumes for each cylinder. So you can draw these out. Again, doesn't have to be perfect. And say, all right, it says radius is 1. Each height, though, is 8. So that's going to be a key part because when you go to find these, make sure that you are labeling that the height for each of them is 8. So find the area of the base for this one. Big B is going to be equal to pi times the radius squared. So that's just going to be 3.14 times 1 squared, which is the same as 3.14. So the area of that base is going to be 3.14. The volume of that is going to be the big B times H, which is just going to be equal to 3.14 times 8. So we're going to say volume equals 25.12. We're going to say centimeters, so cm cubed. All right, let's draw another one here. So we're going to say here's a new one. This is slightly larger because its radius is 2, and its height still is 8. So h equals 8. So we're going to find the area of this base. So we're going to do big B is equal to 3.14 times 2 squared, which is going to be 4 times 3.14, which is 12.56. So we're going to say B equals 12.56. And then the volume for this one is still area of the base times the height. So we say volume equals 12.56 times 8, because that's the height for each of these. And so we're going to say this is going to be 100.48, and then we're going to say centimeters cubed, because we're talking about that volume. So the second one is 100.48. Or sorry, 100, yeah, 0.4. Okay. Then it has, for the last one, its radius is 3, so just slightly larger, do a different color. I'm going to say this radius is 3 now. However, its height is still 8 because that's each of the heights. So we're going to say area of this base is still circular, so we're going to find the area of a circle. So big B is equal to 3.14 times 3 squared this time. So we have 3.14 times 9, which is going to be equal to 28.26. So that's going to be the area of base. Our volume is still going to be area of the base times the height. So we're going to say volume equals 28.26 times our height, which is 8. So we're going to say our volume for this one is going to be 226.08. I'm going to say centimeters cubed. So notice how the changes of each of these work out. As even if your height stays the same, meaning each of these had a height of 8, each of these had a height of 8, it didn't matter. Notice how that small change in the radius will change your volume. There we go. It'll change your volume by a different amount. So as your radius increases, your volume is going to increase a lot as well. All right, so a little bit easier problem. The next one, it says a 1 quart container of tomato soup is shaped like a rectangular prism. A soup bowl is shaped like a hemisphere that can hold 8 ounces of liquid. How many bowls will a soup container fill? Recall that 1 quart is equivalent to 32 fluid ounces. So this one's real simple because all we have to do is set up a one-step equation. So we're trying to figure out, okay, how many 8-ounce containers will fit in X times. So where X equals the number of bowls. We're saying that this has to be equal to 32 fluid ounces because that is going to be 1 quart. So real simple one-step equation, divide both sides by 8 because we're dividing by the coefficient, and we're going to say x equals 4 moles. Do it a little smaller. There we go. So real simple one-step equation. And now lastly, for the bottom one, it says 2 students join a puzzle solving club and get faster at finishing the puzzles as they get more practice. Student A improves their time. Student A improves their time faster than student B. It says part A is to match the students to the lines L and line M. So since it has that keyword faster, we're going to say, okay, that means the slope, so steeper slope. And so which one has a steeper slope? Well, we're going to say line L has a steeper slope because it's decreasing faster. And it makes sense because it's saying the minutes of time that it takes to complete that puzzle. So we're going to say that student A is represented by line L, and student B is represented by line M. So both of them are decreasing, however, line L is decreasing faster, which is why it passes line M, and we say that student A improves the time faster, so that means that line L goes with student A and line M goes with student B. The next part, it says which student was faster at puzzle solving before practice. So if you look at that y-intercept, so always look at that y-intercept first, or that y-axis I should say, we can say that since student B started at 5 minutes to solve a puzzle, looking at that starting point of line M, they had the faster time initially. So look for that y-intercept on that y-axis. Alrighty, and for the X ticket, here's the translation at the bottom, but I'll read it for you out loud. It says the cylinder shown here has a height of 7 centimeters and a radius of 4 centimeters. First, you need to find what is the area of the base of the cylinder. You can express it in terms of pi. Number 2, it says how many cubic centimeters of fluid can it fill this cylinder. Express it in terms of pi. So find the area of the base, find the volume, and then give the decimal approximation to the second question using 3.14. So substitute 3.14 in for pi after you find that volume. So make sure you can have those labels, solve for the area of the base, solve for the volume in terms of pi, and then plug in 3.14 into pi for that part 3. Be sure to replay, rewind, and ask questions as they come up, and as always, super slam that subscribe button.